Hello and welcome to another video. Today we are going to look at mid to long-term capacity planning and along with that Asprova simulation capabilities. We are starting in the so-called aggregated sales plan table. Here we can create various forecasts and simulate with them. In our example we have sales forecasts for the next 2 years. Currently we have selected the input mass style. Here we could add more forecasts. Since humans can read horizontal tables better than vertical ones, there's also the second style, overview forecasts. Here we can briefly see all forecasts of all articles for the next 2 years. For example, 421,875 units of article FC13 are forecasted at the second quarter of the first year. This plan is converted into a leveled sales plan by Asprova to determine daily production. These forecasts are converted into monthly plans. For example, a total of 140,625 units of article FC13 must be produced in April. This is leveled to the available calendar days considering the available shifts. In our example, this corresponds to a daily production of 5,408 or 5,409 units. Making forecasts and leveling them is one thing, but can we meet the demand with the capacity available to us? For that, we switch to the load ratio graph. On the left side are our group resources, the punching machines, the injection molding machines with 110 or 240 kilonewtons, and all the assembly stations. The load of a group reflects the average utilization of all group members. By clicking on the plus, we open the group and see all the group members and their respective load. In addition to the graphical display, we also have the option to display the utilization in a tabular form. Here too we can recognize the capacity conflict at first glance. For each item, the monthly demand, the average utilization per resource group. For items with the code FC13, the R-blocks with a clamping force of 110 kilonewtons are used, and for items with the code FC32, the R-blocks with a clamping force of 240 kilonewtons. And the actual production capacity of the respective month. But let's return to the graphical representation. Thanks to the capacity load ratio graph, we can identify the injection molding machines with a clamping force of 240 kilonewtons as a bottleneck. On average, these run for 6 months with a capacity of over 100%. Let's have a look at the resource members. We can also see that in an individual month, either the capacity of the R-block 3 or 4 also exceeds the 100% limit. All in all, we can conclude that the sales plan or forecast we have made cannot be met with our existing machinery. Now we have to make a decision. Either we accept that we will not be able to cover the demand in time, or we invest in our machinery and buy a new injection molding machine. Thanks to Asprova, you have an easy way to simulate such scenarios and the impact on your production. We simulate the purchase of a machine and assume that delivery will take almost 6 months. We activate the R-block 5 resource and reschedule. I would like to emphasize the following. We are planning the production for 2 years in advance and the recording software is still running in the background as well. Despite all that, the planning only took around 43 seconds. With the third injection molding machine, we can serve all forecasts and even have some free capacity. In Asprova, you can also evaluate your planning based on various KPIs. For example, item prices, profits, return on resources, etc. Due to the various KPIs of Asprova, you can among other things make well-founded decisions about investments or also create more transparency in your production. But that would be too much for today's video, so we will deal with them in another video. I hope you enjoyed this video. For more information, feel free to write us an email or watch our other videos. We are more than happy to clarify your detailed questions with you personally. Thank you.